Hello guys, in this video I'm gonna show you guys how to do a DC sweep analysis using PSpice. So let's go and do that. I'm gonna create a new project. The name I was gonna make it DC sweep analysis. Location. For now I'm gonna put my desktop, but you guys can choose whichever you guys want to, wherever you guys want to. All right. Okay. I'm gonna do this first option here, so that the PSpice analog omics ID and hit OK. So in case you guys are wondering, if I have selected create blank project, it will give me a blank one. But here is some projects already, you can say halfway done, or startups. So just for the purpose of this video, just to show you guys, I'm gonna keep that one so you guys can see what's gonna appear. It says here analog ground symbol. Let's see what happens. Okay, just wait. All right, I'm gonna double click here since it's now opening my schematic, and there we go. So you guys can see they already started with the ground. Simulation's already being set up. I cannot run. If I run, I will get an error message. Let's see what's here. Well, it's blank. Oh. And options, we have this thing. This is going on, but pretty much everything else is blank. Okay, let's cancel that. So I'm gonna go ahead, and to save time, I already created a schematic. There it goes. Let me delete this one. There you go. Okay, and let me see if I can move this more to center. There it goes. Zoom in over here a little bit. That's good. Okay, so what I'm going to show you guys is to we're going to analyze different voltages. Okay, so let's see. Let's get some specification. Let's see. I'm going to do a new simulation profile. It's going to be a DC sweep analysis. Okay, create. So here I'm gonna look for a DC sweep. Okay, the voltage source, mine is on V1, so here V1. Okay, let's see. Now here I'm gonna do it in increments. So start from 5 volts to 10 volts, and let it increment 0.5 every 0.5 volts, and it's gonna be a linear incrementation. Okay, I'll apply here. Now I want to show you. Here on the time is set up that it's gonna every 1000 nanosecond is gonna be this is gonna run for 1000 nanosecond. Okay, just do something for you guys to see there. Back to DC. Okay. Apply. Okay. What else am I missing? Apply there. All right. Now let's go and calculate the voltage. So we can hit that. We can find the voltage in this area if we want to. And let's see. So if I click escape, run it, just wait. Down here, this pops out, this comes out, and here's gonna give us the voltage. You guys cannot see, but let me see. Let me go to tools, options, color settings. Let's see, I don't like it. All right. I'm moving the colors. So I'm selecting right now. Okay, I'm gonna select the blue one and I'm moving it up by clicking up. What this is doing, these are my default colors. So whenever I'm tracing something's being traced, this is the order of the colors gonna come in. Okay. Let me click OK on that one. Let me close this. Let's try this again. Alright, so I'm gonna do PSpice new simulation. No, actually no. PSpice edit profile. Actually, that's not even necessary. No, that would not be necessary. My bad. Alright, we just hit play. Yeah, we'll run it again. Yes. Alright, just wait. It's not changing the color. Let me close that. Yeah, that one. Okay, so you guys can see that doesn't work like that. So let's do new simulation. I want to use the same name. DC sweep. And this is okay. Create. I got it another one with the same name. Just want you guys to see it. Alright. Now what to do? Other options. And at the same time, I'll show you guys different ways. Okay. So you guys, it's yellow. So I'm gonna right click it, trace property. There you go. I should have done this from the beginning. Alright. Change it to I don't know, green. Change the width a little bit more. No, it's a little bit more. Alright, that's okay. And okay. There you go. Alright, my bad. Alright, so that shows that the voltage at that particular point between R2 and R3 is increasing as the voltage of the source voltage increases by 0.5 from 5 to 10. Okay. Let's see. And all this is in a time of 1,000 nanoseconds. Nanoseconds. All right. So that's that. And now let me show you guys. If I wanted, for example, the voltage between, the voltage on R2, I choose this option here that says voltage differential markers. And I'll click here and I click here. Escape, and it'll give me the voltage between those two. Okay, so when I just push play, I'll run and wait. All right, I think now it comes out green. All right, look at my simulation. Right click it, property, trace property, and make it thicker for purpose of for you guys to see it. Because again, so on R2, the voltage increases as the voltage of the source increases. So that means at 5 volts of the voltage source, R2 is 1.5 volts. When the voltage source was, let's see, 6 volts, R2 was 1.5, 6, 7, 8, 9 to 1.95 around there. just estimating. Okay. All right. Let's try another way, other things to see. All right. So as you guys can see, we can find, voltage. Let me delete this. We can find the voltage between and the components, the voltage in a particular area on a node. The same thing with the current. We can find current here. Um, so, so if I want, for example, let's try watts. Yeah, I want the watts, the power here, and the power here. Escape. So I'm gonna go and run it and wait. Yeah, let's change the colors. Okay, let me right click here and adjust the display here. Um, and the green one. I do apologize for any mishaps here, guys. I'll be honest with you guys, I'm pretty much doing freestyle right now. Because I just was wondering to see how it will work if I freestyle these videos. All right. So as you guys can see, the power increases. So power increases as voltage increases, and of course each resistor has their own particular power. They are not all the same since the resistor themselves is different. Okay. Uh, let's see what else. Let's see. Little bit about this window, little exploration, not much, because I'm still working to get. I'm still getting to know this program. Let's see on tools, we can go to options. Let's say we have general. Use symbol properties, never always. Use scoreboard, auto. Trace color scheme, normal. Auto updated intervals, auto. Okay. All right. So so it's an auto. So assuming that these intervals here, they automatically like they have their own increment. They calculate how they want it. See here, if I put every 1 second, I assume this will be every 1 second. Or every 10%, they'll do it with 10%. But since I had it default as running for 100 nanosecond, I assume they bought into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I guess every 10 parts. All right, let's see. Trace call, large data file. Okay, course settings, course colors right here. Oh, so this is the order of colors it's gonna appear. So you guys can see the green one is the bottom one, and we went blue and teal. Yes, and you can change. If I select green, I move down. I can move it up. I'll keep it like that. All right, set all count. Oh wait, font setting. Oh, change label font. See what that pops up. Wait, okay, it's the font. All right. Let's see. Let's see. Now, what if I can find this one that curry ball? I wonder. Let's see. I want to go to on the next time I go away. I wonder if I hit here with the refresh running. Yes, but I have to redo this again. Okay. All right. So that's with that. What else? Oh, it's an undo here. If I don't, nothing works with the undo. Okay. So now. So that's that. Oh, there's also another way you can. All right. So let me show you this example. All right. So guys, there's another way you guys can also do these types of analysis. You guys can go, for example, if I want the voltage between or in the voltage drop here or the voltage in its components, I can choose this here and I can go ahead and choose run. Just wait. Okay. So open this. Let me right click it here, make it increase the width. Okay, so the voltage in that component is this. Now, if I want to instead of doing it like that, I can also go to trace, hit add trace, and then go to and to avoid all this stuff going on. Let me unselect power, unselect this, that's good because I'm only looking really for VR1. So if the voltage of resistor 1 from one end dash to the other end, okay, and you guys cannot see it, but it's on top of my line. Let's see, trace. I wonder if I can, yeah. So it's actually on top of my line. And right here in the bottom, you guys can see that the green one is R1, R11, R21. And the blue one is R1, R12. Oh, I had it backwards. Yeah, that's what that means. The same thing as that. Let's see. Hard trace. So if I do, cause this down here is the little formula. All right, so if I do R11, comma, R21. No, wait. No, that's the right way. Yeah. Yeah, that's the right way. Yeah, because it's living on top of there. Okay, if I've done that with a comma, let's see what happens. See? Yeah, it will come out weird. All right. So, yeah. So anyway, so let me hit that. Oh, no, okay. All right. So that's another way you can do it. Instead of putting the voltage here, you can also, when you're in this page or in this window, you can go to trace, add trace, and indicate where you guys want your current or whatever. Okay. All right. So that's one thing. Let's see what else. Okay. Cancel that. I can also go trace, delete all trace. That'll clear the whole thing. Close that. Let's see. All right, guys. That's it for now. See you guys next time. Bye.